November 19, 1944, Hürtgen Forest, Germany. 6:23 hours. The cold bites through wool and steel. Frost clings to the trees like shattered glass, and the forest floor is a churned mixture of mud, blood, and the shredded remnants of men who believed in something larger than themselves. In a clearing that might have been beautiful in another life, a Sherman tank sits motionless, not destroyed, not abandoned, but broken in a way that matters more than death in this mechanized war. The final drive housing is cracked, transmission fluid mixing with hydraulic oil in a pool beneath the chassis that reflects the grey dawn like a mirror of futility. By every regulation, by every field manual, by every reasonable assessment, this tank is finished. Salvage the guns, strip the radios, mark it for recovery whenever the roads are clear and the war moves on. Staff Sergeant Curtis Cullen stands in that oily pool, hands black to the elbows, and says one word: no, he is not a tanker. He is not an officer. He is a maintenance supervisor with the 102nd Cavalry Reconnaissance Squadron, a man whose job is to keep jeeps running and half-tracks moving, who has never commanded armor in combat, who has no authority to countermand the assessment of men who have been fighting in these machines since North Africa. But Cullen has something else: 20 years of Depression-era mechanical improvisation. A father who taught him that every machine wants to work if you understand what it's asking for, and an absolute refusal to accept that complexity equals impossibility. The tank crew, 5 men who have survived 3 months of hedgerow hell and forest fighting, watch him with the particular skepticism soldiers reserve for rear echelon optimists. They have already grieved for their tank. They have already begun the psychological process of bonding with the replacement vehicle. They do not want hope. Hope in the Hürtgen forest is a luxury that gets you killed. Cullen pulls a wrench from his tool bag and begins disassembling components that the technical manual says cannot be field serviced. He does not ask permission. He does not request authorization. He simply begins, and in that beginning, something shifts. Not in the metal, not yet, but in the men watching. Because Curtis Cullen is not looking at a broken tank. He is looking at a problem that can be solved if you are willing to ignore everything you have been told about what is possible. The Sherman tank was never supposed to be in the Hürtgen forest. It was designed for the open terrain of North Africa, for the sweeping tank battles across desert where visibility extended to the horizon and maneuver was the decisive factor. The Hürtgen was the opposite of everything the Sherman's designers had imagined. Dense forest, where trees grew so close that 2 men could barely walk abreast. Roads that were logging trails, transformed by military traffic into mud channels deep enough to swallow vehicles. Slopes so steep that tanks had to winch themselves up using trees as anchors. The final drive, the geared reduction unit that connected the transmission to the tracks, was engineered for reliability under normal combat conditions. In the Hürtgen, normal did not exist. Tanks climbed grades that exceeded their design specifications. They pivoted on slopes, where the weight distribution created stresses the engineers had never calculated. They operated in mud that created suction against the tracks, multiplying the force required for every movement. The result was predictable. Final drives cracked, failed, and condemned tanks to immobility in a forest where immobility meant death. The standard procedure was replacement. Remove the entire assembly, install a new one, a job requiring a crane, a maintenance depot, and 6 to 8 hours of work by trained technicians. In the Hürtgen, there were no cranes. There were no depots within 20 miles of the front line. There were no 8-hour windows where a disabled tank could sit peacefully while mechanics worked. There was only the forest, the enemy, and the increasing pile of armor that the official reports classified as combat losses, but which soldiers knew were simply machines that had been asked to do the impossible and had broken. Cullen had seen 12 tanks condemned in 2 weeks. 12 vehicles with operational guns, working radios, intact armor, and crews who knew how to use them, all abandoned because a single component had failed. It offended him in a way that transcended military efficiency. It was wasteful, yes, but more than that, it was a surrender to the idea that machines were disposable, that when something broke, you simply replaced it rather than understanding why it broke and how it might be fixed. His father had run a garage in Newark during the Depression, had kept cars running that should have been scrap, had taught young Curtis that every mechanical failure was a message, the machine telling you what it needed. What stress had exceeded what tolerance, what fundamental principle of operation you had misunderstood. You did not throw away a machine because one part failed. You fixed the part, or you made a new part, or you changed how the machine was used so that the part would not fail again. The problem was authority. Cullen was a sergeant. The tank belonged to a cavalry squadron with its own maintenance section. The decision to abandon the vehicle had been made by a lieutenant who understood regulations and liability. If Cullen attempted repairs and failed, he would be responsible for the time wasted and the resources expended. If he succeeded, he would have violated the chain of command by overriding an officer's decision. The rational choice was to walk away, to let the system function as designed, to accept that this was someone else's problem. Curtis Cullen had never been particularly good at rational choices. The first challenge was diagnosis. The official assessment, catastrophic failure of final drive housing, was accurate but useless. Cullen needed to know why the housing had cracked, what stress pattern had caused the failure, whether the damage was isolated or symptomatic of broader mechanical degradation. He crawled beneath the tank, 30 tons of steel balanced on improvised jacks that would kill him instantly if they failed, and spent 2 hours with a flashlight and a screwdriver, mapping the fracture pattern, testing each bolt and gear, building a mental image of how force had flowed through the assembly until something gave way. What he found was both worse and better than expected. The housing had cracked along a weld seam, a manufacturing defect probably, where the metal had been stressed during fabrication and the repeated shock loads of Hurtgen combat had finally propagated the failure. But the gears themselves were intact. The bearings were scored but serviceable. The fundamental components of the final drive were functional. Only the container had failed. In a depot, the solution would be simple: replace the housing. In the Hurtgen forest, there were no replacement housings. There were, however, 2 destroyed Sherman tanks within half a mile, both victims of German anti-tank guns, both with final drives that had survived even as the rest of the vehicle burned. Cullen assembled a work crew, 3 men from the tank crew, 2 mechanics from his own section, and 1 welder who had been operating a bridging unit and who owed Cullen a favor involving bourbon and a poker game. He explained what he intended to do: remove the intact final drive from one of the destroyed tanks, swap it into the disabled vehicle, adapt the mounting points to compensate for slight differences in manufacturing tolerances. The tank crew listened with the careful neutrality of men who had learned not to hope. The mechanics listened with the professional skepticism of men who understood how many ways this could fail. The welder listened and asked one question: "You got authorization for this?" Cullen did not. He had initiative, which in the army was supposed to be encouraged right up until the moment it caused problems, at which point it became insubordination. He made a decision that would either end with a commendation or a court-martial, and possibly both. I'll get it retroactively. Let's move. The work began in darkness and continued through a day when German artillery reminded them every few hours that the forest was contested ground. Removing the final drive from a destroyed tank was archaeology and butchery combined, cutting away damaged metal, disconnecting systems that had fused in the heat of fire, extracting components that had been engineered for installation in factories, not removal in mud. The first unit they pulled was too damaged. The housing cracked in the same pattern that had disabled the original tank. The second unit, from a Sherman that had taken an 88mm round through the turret. Killing the crew, but leaving the drivetrain intact, came free after 6 hours of work that left every man exhausted and filthy. Installing it was worse. The mounting points did not align perfectly. The bolt holes were offset by fractions of an inch, negligible in a factory, impossible in the field. Kulin's solution was brutal and effective. Elongate the holes with a drill. Use larger bolts with custom-cut washers to distribute the load. Weld reinforcement plates where the stress concentration would be highest. The welder worked by flashlight, the acrid smoke of burning metal mixing with the ever-present smell of cordite and decay. When the bolts went in, they went in crooked. When Cullen torqued them down, the wrench slipped and he gashed his hand to the bone. He wrapped it in a rag and kept working. By the second day, word had spread. Soldiers came to watch, not many because the Hürtgen forest was not a place where men had leisure to spectate, but enough. They came during lulls in the firing, stood at the edge of the clearing, and watched Curtis Culin do something that the manuals said was impossible. Some of them were tankers who had lost their vehicles and were waiting for replacements that might never come. Some were infantry who were simply curious about anything that broke the monotony of cold and fear. All of them understood on some level that they were watching something significant, not because the tank mattered strategically, but because someone was refusing to accept that broken meant finished. On the third day, the final drive was installed. The transmission fluid refilled, the hydraulics bled and tested. Cullen climbed into the driver's position. He was not a tanker, had never driven a Sherman in combat, and started the engine. It coughed, caught, rumbled to life, with a sound that was simultaneously mechanical and miraculous. He engaged the transmission. The tank lurched forward 6 inches and stopped. The crew groaned. Cullen shut down, crawled back underneath, found that a hydraulic line had blown. Not his work, but a failure in a weakened component stressed by 3 days of vibration. He replaced the line with one scavenged from a Jeep, adapting the fittings with brass compression couplers that had no business working but did. He started the engine again. This time the tank moved. It pivoted, tracks churning mud, final drive housing holding, all the improvised welds and oversized bolts and jury-rigged connections functioning together in a symphony of mechanical improbability. Cullen drove it in a circle around the clearing, then returned it to its crew, shut down the engine and climbed out. The tank commander, a lieutenant whose name Cullen had never asked, stared at him with an expression somewhere between awe and terror. "How the hell did you do that?" Cullen wiped his hands on a rag that had long since ceased to have any cleaning capacity. "I just fixed what was broken. That's not supposed to be possible." "Possible," Cullen said, "is a word officers use when they want to explain why they can't do something. The symbolic object in this story is the wrench, not a specialized tool, not a piece of high-technology equipment, but the standard adjustable wrench that Cullen carried in his tool bag. Its jaws worn smooth from years of use, its handle wrapped in tape where the grip had cracked. He used it for everything, removing bolts that required delicacy, hammering pins that required force, prying apart components that had corroded together. It was the wrong tool for most of the jobs he attempted. It was also the only tool he needed, because Curtis Cullen understood that the right tool was whichever one you could make work. The wrench represented something the Army struggled to codify. The difference between technical proficiency and mechanical intuition. The field manuals taught procedures, step-by-step instructions for maintenance under ideal conditions. Cullen operated on principles, understanding how force flowed through a system, how materials responded to stress, how components could be adapted beyond their designed purpose if you understood their fundamental function. He did not follow the manual, because the manual was written for depots with cranes and replacement parts and time. He followed the logic of the machine itself, the conversation between component and stress, metal and force, design and improvisation. This was not recklessness. Cullen tested everything. He calculated stress loads in his head, compared them to what he remembered about material strengths, added safety margins where he could, and accepted risk where he could not. His repairs were ugly, welds that would make a factory inspector weep, bolt patterns that violated every standard, solutions that no engineer would approve. But they worked. They worked because Kulin understood that engineering is not about elegance. It is about function. A perfect repair that requires unavailable resources is useless. An ugly repair that restores capability is everything. Word of the impossible repair reached the squadron commander within hours. Within days, it reached division headquarters. The response was predictably bureaucratic. Kulin was commended for his initiative and reprimanded for his violation of procedure. He was awarded a Bronze Star and simultaneously informed that he was not authorized to perform major mechanical repairs on vehicles outside his assigned responsibility. The contradictions did not bother him. He understood that institutions must maintain rules even when individuals must break them, that the army needed both the regulations that created order and the men who ignored those regulations when necessity demanded it. But the story spread faster than the official response. Tankers throughout the division began bringing their damaged vehicles to Kulin, or requesting his presence when a breakdown occurred. He became a legend in the way that only specialists can in wartime, not famous to the wider world, but essential to the men who depended on machines to keep them alive. He fixed final drives with parts from 3 different tanks. He rebuilt transmissions using gears cut from farm equipment. He kept a Sherman running for 6 weeks after the engine should have seized, using a lubrication system improvised from hydraulic fluid and prayer. The tank he had first repaired, the one the manuals said was impossible to fix, fought through the rest of the Hurtgen campaign. It survived the bulge, crossed the Rhine, and was in Czechoslovakia when the war ended. The crew named it Kulin's Miracle, painted the name on the turret in defiance of regulations prohibiting personal markings. When they were ordered to turn in their vehicle at war's end, they requested permission to keep a piece of it, specifically the final drive housing with its ugly welds and oversized bolts. The request was denied, but someone in the disposition unit understood what they were asking and looked the other way when a certain component went missing from the salvage inventory. After the war, Curtis Cullen returned to Newark, opened a garage, and spent 40 years fixing cars. He did not speak much about the war. When veterans organizations asked him to share his story, he declined. When military historians researching the Hurtgen campaign tracked him down in 1978, he granted a brief interview in which he described his work as just doing what needed doing. The historian asked him if he understood that his techniques had been studied, that his field repairs had influenced post-war maintenance doctrine, that the Army had revised its manual to include procedures for emergency final drive replacement based on methods he had improvised. Kulin shrugged. The manual needed updating. Took them long enough. Do you consider yourself an innovator? An engineering pioneer? I consider myself a mechanic. A good one, maybe, but just a mechanic. You did things the experts said were impossible. The experts, Kulin said, weren't standing in the Hurtgen forest in November with 30 tons of good metal and a crew who needed their tank. Possible looks different depending on where you're standing. There is a photograph from December 1944 taken by a Signal Corps photographer who was documenting maintenance operations. It shows Cullen beneath a Sherman tank, only his legs visible, torque wrench in one hand. Surrounded by the detritus of mechanical surgery, scattered bolts, discarded gaskets, tools laid out on a canvas tarp in organized chaos. The photograph was not published during the war. It was not dramatic enough, contained no combat action, showed none of the sanitized heroism that censors preferred. But it circulated among veterans, passed from unit to unit, and eventually found its way into maintenance training materials with the caption, Field Expedient Repair, Hurtgen Forest, 1944. What the photograph does not show is the context, the frozen mud, the sporadic artillery, the dead men in the trees waiting for Graves registration to reach them. the exhaustion that made thought difficult and precision nearly impossible. It does not show the courage required to crawl under 30 tons of steel that could crush you if the jacks failed, to work for days on a repair that might not succeed, to stake your reputation and possibly your freedom on the conviction that you could fix what officers had declared broken beyond repair. The photograph shows a mechanic working. What it means is that sometimes the most important battlefield is the space between accepting failure and refusing to quit. The technical achievement was real. Kylin had performed repairs that required equipment he did not have, in conditions that precluded precision on a timeline that eliminated caution. But the impact transcended the mechanical. Every tanker who saw that repaired Sherman understood something, that machines were not disposable, that resourcefulness could substitute for resources, that one man with knowledge and determination could change the equation of possibility. In a war increasingly defined by industrial scale and mass production, Kylin represented an older tradition, the craftsman who understood his materials, who could coax function from failure, who refused to accept that complexity meant fragility. The army tried to replicate his methods. They published technical bulletins, updated field manuals, created training courses on improvised repair. They could teach the procedures, but not the mindset. Kylin did not follow a checklist. He conversed with machines, listening to how they failed, understanding what they needed, adapting his solutions to the specific damage rather than applying generic procedures. This intuition, this ability to see past the apparent to the actual, cannot be taught in classrooms. It requires years of failure and success, of breaking things and fixing them, of developing the feel for how metal behaves under stress, how tolerances accumulate into catastrophe or cancel into functionality. By the end of the war, Kylin had repaired 47 tanks that had been officially designated as total losses. Some of his repairs lasted days, some lasted months. One tank he had fixed in January 1945 was still operational in July, its improvised final drive outlasting 2 factory replacements. The variance did not bother him. He understood that field repairs were temporary. They were designed to restore immediate capability, not to last forever. Their purpose was to get the machine and its crew through the next engagement, the next day, the next hour. This philosophy prioritized function over longevity. Accept imperfection in service of necessity was alien to institutional military thinking. The army wanted standardization, predictability, repairs that could be documented and replicated. Kylin's repairs were unique to each situation, dependent on available materials and his assessment of what would work. They could not be standardized because they required judgment, and judgment could not be reduced to protocol. The tension between Kylin's effectiveness and the army's need for systematization was never resolved. He continued to repair tanks his way, and the army continued to write regulations he ignored. And somehow both sides accepted this arrangement. Because the alternative, tanks, sitting disabled while paperwork determined their fate, was unacceptable, the lesson is not that rules should be broken or that individuals know better than institutions. The lesson is that complex systems require both, the framework that creates order and the flexibility that handles exceptions. Curtis Kylin could do what he did because the army gave him training, tools, and context. But the army could not give him the wisdom to know when to ignore what he had been taught. That came from experience, from failure, from the accumulated knowledge of how machines behave when stressed beyond design limits. It came from caring enough about metal and men to refuse the easy answer of abandonment. This is the epilogue written in oil and steel, that engineering is not about perfect solutions, but adequate ones. That the best repair is the one that works with available materials and time. That genius sometimes looks like stubbornness, and stubbornness sometimes achieves genius. Curtis Kylin did not change the war. His repairs did not affect strategy or alter outcomes. But he changed the equation for dozens of crews who needed their tanks, who depended on machines to keep them alive, who learned that broken did not mean finished if someone cared enough to try. The wrench he carried through the war sits now in a military museum, donated by his daughter after his death in 1992. The label reads, Field Maintenance Tool, WW2 European Theatre. It does not mention Kulin by name. It does not need to. The men who knew him, the crews who drove tanks he had declared repairable when officers had declared them lost, they know. They know that wars are won, not just by soldiers who fight, but by mechanics who refuse to quit. Not just by machines that work, but by men who understand that nothing is irreparable if you are willing to try. The impossible repair, the legend in the Hürtgen forest, the mad mechanic who fixed what could not be fixed, these are not myths. They are memory, rendered in metal and testified to by men who fought in tanks that should not have run but did, because Curtis Cullen looked at broken things and saw only problems waiting to be solved. That is the trick that defied impossibility. Not superior technology, not unlimited resources, but the refusal to accept that complexity equals defeat. That when something breaks, you can always try to fix it. The tank kept running. That is the whole story, and it is enough.